Okay, welcome back to another video on my channel, math_exe. And today, as you saw in the beginning of the video, I have taken a short video of a question, and I'm going to show you the solution to that. So we know that Angela, I'll just draw a diagram right here to present her home and her school right here. And from that question, we know the distance between her home and her school is 2.5 kilometers. And she left her home at 6:30 and reached her school at 6:55. So you need to find the average speed for this journey in kilometers per hour. So first you can just find the time needed for Angela to travel this distance, and you can just simply subtract the times right here, and you notice that this will leave us in 0.25, which means 0 hours and 25 minutes. And since we want to make it into kilometers per hour, it's probably best to change this into a fraction in hours. So you can just divide this by 60, because 1 hour is 60 minutes, and this will leave us into a simplified fraction of 5/12 hours. And we're ready to use our average speed formula. So remember, our average speed formula is the total distance traveled over the total time needed to travel that distance. So in this case, our total distance is 2.5 kilometers, and this is over 5/12 hours. And you can just rewrite this as 2.5 kilometers divided by 5/12 hours. And perhaps I'll just rewrite 2.5 kilometers as an improper fraction, because that will be easy for our division of fractions later. So 2.5 will be just equal to 5/2, and don't forget the kilometers. And now we're ready to do the division. So we have 5/2 kilometers, and if we have a division, the numerator and the denominator will switch places, and this will change in the a times. So we have 12/5. And perhaps I'll just move the units right here, since we already know this will be kilometers per hour. And you notice some cancellations occur. So this 5 and this 5 will cancel. This 2 and this 12 will cancel, leaving us with a 6. So our final answer is 6 kilometers per hour. And that's our answer for our A part. And perhaps I'll just denote this first. There we go. Okay, for the B part, it says on Tuesday. I'll just draw another diagram right here. This is her home and this is her school. The distance will be the same as shown in the question before. However, her times are different. This will be still the same. However, the arrival time at school will be 6:50. And we need to find the percentage increase in her speed and this day. So it's probably good to find the average speed for this journey, this day I mean. So first we need to find the time, this total time. So we can just subtract the times like before, and we're left with 0.20, which is just 20 minutes. And since we found our answer in kilometers per hour in the A part, it's probably best to do so also in the B part. So 20 minutes, if you count that, it will be equal to a third of an hour, like so. And now we're ready to count our average speed. So remember our average speed formula. I'll just rewrite this right here. So total distance will be 2.5 kilometers. And our total time will be 1/3 hour. And again, like our last step before, we just write this as a division of fractions. And again, it perhaps be best to change this into an improper fraction as well. So 5/2 kilometers divided by 1/3 hours. So let's do our division of fractions business. So perhaps I'll just make this a brackets, and I'll just write the units on the front. So the numerator and the denominator will change places, leaving us with 3/1, or just 3 in particular. So notice this will become 15/2 kilometers per hour, or will be just 7.5 kilometers per hour. Now I need to remind a formula for percentage increase. So just rewrite this percentage increase, and this occurs if you have a initial value and a new value, I would say. So the value of the initial value will increase to the new value, meaning that the initial value will be less than the new value. So our formula goes like so. We have our new value minus our initial value, or the difference in values or something. And this is all over our initial value. And then since this is a percentage, it's probably best to multiply by 100%. So in this case, our initial value will be our speed at Monday, or our speed at the A part right here. So this is our initial value, and our new value will be 7.5 kilometers per hour, and we can just substitute them into the formula. So our new value is 7.5 kilometers per hour minus our initial value, which is 6 kilometers per hour, over 6 kilometers per hour, and this is multiplied by 100%. Alright, and looking at the numerator, we'll get 1.5 kilometers per hour over 6 kilometers per hour, and remember this is multiplied by 100%. Notice the units will cancel, and you can just represent this as 1.5 over 6.0, something like this. And then you can just multiply the numerator and the denominator by 10, and then you can see that this will become a quarter. It will simplify into a quarter, and this is multiplied by 100%, and which is just equal to 25%. So for our B part, the percentage increase is 25%. I will do some more examples just a bit later. Alright, for the second question, it's always probably best to follow a diagram first to kind of like make a picture in your mind about what the question is talking about. So in this case, the car travels from city A to city B. So this is A and this is B. In the first half, it travels at a speed of 45 kilometers per hour. And in the second part, from B to A, it doubles its average speed or speed. It is 45 times 2, so we can just write 45 times 2 kilometers per hour. And you might already think this is 90. So yeah, 90 kilometers per hour. And it's also given that the distance between city A and city B is 180 kilometers. So we need to find the average speed of the car for the entire journey. So from A to B and then back to A. So something like that. So first, it's probably good to kind of like figure out what your total distances and total times are. So for total distance, since it travels from A to B, so it travels 180 kilometers, and then back from B to A, so it travels yet another 180 kilometers. So we have 180 kilometers plus 180 kilometers. This will be equal to 360 kilometers. Alright, and for total time, it's probably best to find the time for the first part. So we know our time is just the same as the distance over the speed. So in this case, for our first part, I'll just rewrite this as t1, and then we need to find what t2. T2 is the time needed for the second half. So for t1, we need our distance, which is 180 kilometers. That's the distance traveled for the first half. And then for our speed for the first half, it's 45 kilometers per hour. And then for the second part, we have 180 kilometers. That's our total distance covered for the second part. And then for the speed, we'll have 90 kilometers per hour. There we go. And then quickly evaluating this, this will become 4 hours. This will become 2 hours, which is totally 6 hours. Alright, and to finish it off, remember our average speed formula is this: the total distance over total time, which is just in this case 360 kilometers over 6 hours, which is 60 kilometers per hour. And perhaps I'll do one more example about this type of question. Alright, for the third question is a pretty interesting one. However, it is, if you already know the trick, it is very easy to solve. So it says that two cars, I'll just draw two separate diagrams to represent this. So two cars, car A and car B, are having a race. It's also known that car A had a 3-second head start, so car B stopped for 3 seconds and then go afterwards. So car B started going at around this point right there. And it is also known that the length of the race is 540 meters. Oh, and also I forgot, car A is traveling at an average speed of 60 meters per second. Alright, and we need to find what is the minimum speed for car B needed so that car B wins the race. So obviously car B has to have a greater average speed than car A, otherwise the car B will lose the race, obviously. So as soon as car A reaches here, and then car B goes right here, and then car B must be as fast as possible so that he wins the race, something like that. Alright, so first let's just find the time needed for car A to complete the race if its average speed is 60 meters per second. So I'll just write as S of A. S of A means speed of car A. It will be the total distance covered by car A, which is 540 meters, just the length of the race, over its average speed. So I think it's perhaps pretty useful to find the time needed for car A to complete the race. So I just write as T of A. T of A meaning time taken for car A to complete the race. Alright, so we know it is just the same as the distance over speed. So in this case, our distance will be 540 meters and our speed will be 60 meters per second. And after evaluating this, we get our time needed is 9 seconds. So what I mean before by we need to let B win the race is that B has to have at least the same time as car A to finish the race, since race is counted as time. So since car A has a head start of 3 seconds, that means car B has only a shorter amount of time to complete the race, and that is the total time for car A to complete the race minus car A's head start, which is 3 seconds, and that will be 6 seconds. And if you think logically, car A has more time because he has a head start, and car B has less time because he has to stop for 3 seconds and then he can gas. So after you reach this point, you pretty much you're pretty much good to go. So you only need to find the speed, the minimum speed for car B. So this is just the total distance traveled over the total time. So our total distance will be 540 meters. Our total time will be 6 seconds. And this will be 90 meters per second. So car B has to have a average speed of at least 90 meters per second to at least win the race or have a draw. And so then that it will be too slow for car B to win, and too fast it doesn't really matter because car B will still win anyway. So I think that's it for some examples of this average speed type questions. So hopefully you guys enjoy this video. Please subscribe for more videos because I'll be uploading more videos in the future. And I'll see you guys next time. Goodbye.